Okay, this is just a short video, hopefully, just to give a little bit of hint on question 2, part 3, and then also question 3 as well, or at least part of that, just to give you an idea about how we approach it. Now, for part 3, we have got a box. There's a force that we're pulling it that way. Hopefully you got that as negative 30I. We have the weight of the box pulling it down. We have this other force, F2, 48I minus 87J. I is going right and J is going up. Therefore, this is going right and down. So the other force is pulling it here. And we're going to assume we've got this other tension, T2, that we need to find. We're just going to work out what T2 is. Now, the box is in equilibrium. That means when I add everything together, we're going to end up with a net result of 0, okay? So that means because it's in equilibrium, if I start by looking at the i's, as it's in equilibrium, they're going to equal 0. So if I look at anything that's giving me horizontal movement, I know that F1 plus F2 plus T2 are going to give me 0. If I look at the i's, that's negative 30, 48, and whatever I get from T2. Well, negative 30 and 48 are going to give me 18. So 18 add T2 is 0. So that means that the i's must be 18. If I now look at the j's, if I repeat this for the j's, okay, I'm now going to be looking at anything that's moving, any vertical movement on this. Okay, what I know here is that the weight and F2 and T2 are going to equal 0. Okay, now, if I'm taking this as J as being positive or going up, that means that the weight is got to be negative. So I'm going to have minus 5 lots of G for gravity. I'm going to add on this bit here, which is negative 87, and then add on T2, which is 0. Okay, now, if I look at that, sorry, just check it. 5G, G is negative 9.8, or G is 9.8. That basically means I'm going to get minus 49, take away 87, add T2 is 0. In that case, adding those together, T2 has got to be 138. And so that means that T2 equals A lots of I and B lots of J. A is there, B is there. Okay?